As the holiday season approaches, Jam and I are very excited to announce that we're rolling out another round of merch for the show. We had a great response last time. There were several people who mentioned that they missed out, and we thought it would be perfect in case you know someone who would like this gift for the holiday season. Our classic logo stuff will be back, plus we have some new designs that were commissioned from friends and artists. There's even a special chemistry Christmas tree shirt that I'm really excited about.
Part of the reason we're doing this is also to fundraise. So Melissa and I love making this show and want to do it for a lot longer. But currently we still have some annual fees that haven't been fully covered. Our goal with this merch campaign is that we'll be able to cover the costs of making the show for a whole another year.
To check out our store, go to bonfire.com/store/chem4yourlife. That's chem, F-O-R, your life. Or you can check out the link in our show notes, on our website, or in our social media bio. The last day to buy anything from our store is November 30th. We're doing our best to make sure everyone gets their stuff by the upcoming holidays. So go check it out and help us share chemistry with even more people. And now, on to the show. Hey, I'm Melissa.
I'm Jam.
And I'm a chemist.
And I'm not.
And welcome to Chemistry for Your Life.
The podcast to help you understand the chemistry of your everyday life.
Not bonus edition. For some reason, I expected you to say bonus edition just then. Jam, what's up? How are you doing today?
Dude, I'm good. I'm tired. I've been burning the midnight oil and stuff, but I'm good. I've got coffee. We'll get through this. I'm here. I'm ready for some chemistry. How about you?
Are you burning the midnight oil because of being a dad, because of booming success on your Fiverr business account, or what?
I guess they're related, because the best times to work on stuff, if I have a lot to work on and I'm being a dad a lot of the days of the week, is at nighttime when our baby's already asleep. So
yes,
there've been a few nights lately that I've been up late catching up on work because it's a time I can get a lot done. But yeah, certainly not the best for my sleep and my health. So hopefully I can get that under control.
I'm often worried about Jam. He messages me long after I've gone to bed, very often, and replies immediately when I wake up, which is concerning because that means he's awake too. Again, or still, either way, concerning.
Yeah, I'm sorry for texting you so late. So now just like, okay, if I respond to this now, or like I have these thoughts, it's the best time to do it right now because I might forget later. And I always hope when I text somebody really late that they are someone who doesn't have their phone like right next to their head or something.
I don't.
Okay, great. Because it's just like one of those things where I'm just doing it for now, hoping that you'll see it later. That I probably...
Yes, I have my notifications turned off on my phone, so nothing comes through except phone calls.
Awesome.
So today's topic, Jam, is going to be really relevant to you. It's something that you do a lot, all the time.
Okay.
And that's nail polish.
Oh, right. Yeah, definitely relevant to me.
Have you ever painted your nails or someone else's?
I think I have. I remember using like my mom's nail polish. She had like some spare ones and stuff like that. I think we like paint our nails for fun sometimes, my brothers and I. And then also, I remember using the nail polish on other stuff, like I think rocks. For some reason, I just remember us nail polishing some rocks, including like the clear coat stuff on rocks as kids.
Nice. Okay, well, then you will know a little bit. That's good, because you'll know a little bit about how nail polish works. So the very basics of nail polish, I mean, it's all chemistry, of course. But the very basics.
Wait, before you say this, before you say that word you almost said, can I ask, is nail polish a polymer?
Yes. How'd you know?
I actually thought about that and I was like, I really want to make this guess before we actually start in, because of all the polymer topics we've covered so far, slowly I feel like a little bit of a category is starting to build up in my brain of the things that seem kind of like they should fit into the polymer category. And when you've got like super glue and stuff, for instance, and the coatings on nonstick pans and stuff like that, where I'm like, I feel like if it's not a polymer, then what could it even be in this case?
Wow. Well, I'm very impressed. Yes, it's a polymer, and it's a polymer dissolved in a solvent. And a solvent is usually just a medium which some kind of solute is dissolved in. In this case, the solvent is an organic liquid that evaporates pretty easily.
Okay.
So you've got your polymer dissolved in your solvent, and you put it on your nail, and it evaporates, leaving a film.
Nice.
So that's sort of the whole story, but actually there's more to it.
Okay.
There's a lot more chemistry to it. But I'm really proud of you for knowing that it was a polymer. For those of you who this is your first episode listening, or maybe you're listening in reverse order, we've talked a lot about polymers. So check it out in the nonstick pan episode, the cast iron episode, the episodes about plastics. All of those cover polymers. And really what a polymer is a long chain molecule. It's a large molecule made up of a lot of repeating units of smaller molecules that Jam made up the term for molecules. In science, we call those monomers and polymers, but Jam likes to call them molecules and then a big molecule.
Yeah, it's fun, and it kind of makes its meaning obvious a little bit.
Yes, very obvious. I think they could have made it that, So that's the basics, is this polymer dissolved in solvent. You put it on your nail, the solvent evaporates, and then you're left behind with a nice film. But practically, there's a lot more chemistry to it.
Okay.
So nitrocellulose is the polymer that forms the film, but oftentimes it's not going to stick to your nail as well. So scientists have added in adhesive polymers that make sure that the film adheres to your nail. Okay. So they're almost like a primer of some sort that helps it stick. I don't think it goes on in the primer layer and then the other layer, but all mixed in, but it helps it stick better to your nail. It wouldn't naturally stick to your nail.
Okay.
Also, some polymers can be brittle and chip. So they add other molecules called plasticizers that fit in between your polymer chains. So you have these polymer chains, and then plasticizers go in between them. And plastic basically just means bendier in this case. So they make it bendier, more flexible, so that it won't chip by spreading your polymers out a little bit. So they're not so brittle, tightly packed in together. So you've got your polymer that makes the film. You've got your adhesive polymers, and you've got some plasticizers that spread your polymers out a little bit to make it bendier so it doesn't get brittle and chip. Most of those things are probably not going to be highly colored. So then they also add in pigments to make it pretty colors, and sometimes shiny particles so that it's shiny and cool, glittery, whatever. And then to keep all those pigments and things from separating out to the bottom, they add thickening agents to make it thicker.
Okay.
And finally, we've learned that sunlight can mess up molecules, UV active light. So to keep the color from fading in the pigments, which could react with UV light, they will add sunscreen particles in. So particles which will absorb the UV sunlight and dissipate it without the pigments being impacted.
Oh, wow.
So nail polish seems really simple, but it is actually much more complex because it has to have the polymer, the adhesive polymers, the plasticizers. It's got to have something that makes it pretty. So there's pigments and other shiny particles in there. And then thickening agents to keep it all mixed up. And finally, sunscreen.
Dang. It's like 6 separate chemistry lessons all in one tiny little bottle.
I know. It was kind of hard to decide how I wanted to do this lesson, because it's so complicated, kind of. It's so simple in one way once we know the background of polymers, but it's so much more complicated when you know all the other stuff that's going on at the same time.
Yeah. Wow.
So that was all I had to teach for you today. Is the basic idea that a nail polish is a polymer dissolved in a solvent, and that you paint it on and it leaves a thin film. But that it has a lot of other chemical components that scientists are manipulating these molecules down at the molecular level They're manipulating the interactions between molecules and between the molecules in your nail and between the molecules in the environment to make the color long lasting on your nail and against the sun. So would you like to try to teach that back to me?
Yes, I would love to.
Once you do that, I've got some fun little tidbits of info for you.
Okay, I've kind of been digging deep to try to throw together an analogy for this weird scenario, and I'm not positive it'll work, but I'd like to try. So,
okay.
I was thinking, like, what if you could, one of the things I think that is so cool is to try to visualize this kind of stuff, especially whenever, in this case, in this little bottle of nail polish, so much is going on.
So much is going on. They're so complex.
So what if we could shrink ourselves down and we could see this nail polish being applied to a fingernail?
Okay.
And so what if the kind of main part, the polymer chunks that we saw were like a, ceramic or porcelain plate, just like tons of those, just as far as you can see.
Yeah.
So it's being applied, and it's all mixed into this bottle with all this stuff, including the first, you said the solution, which is what, or the solvent, right? Or whatever.
Solvent, right.
That will evaporate, leaving behind the polymer and some other things.
Right.
So if you have all of these like porcelain plates, as far as you can see, and then that solvent dissolves, what keeps them all there together? And what could, like, wouldn't they just all be sliding around and everything? So you need something to then try to attach them to the nail more than just the polymer on its own would.
Okay.
So then you get tons of glue, mix it in there. And so now the stuff evaporates, the solvent evaporates. But okay, good. At least all the very tiny porcelain ceramic plates are at least, they're all glued to
They're
the
all
fingernail.
glued down. Yes. To your fingernail. This is a good image.
So they're everywhere. You're looking all around, they're everywhere, and they're stuck there. Another downside is that you can't really bend a plate like that. You cannot.
Right.
It doesn't have any give to it. So say you push on a fingernail a little bit. Obviously, our fingernails can bend a little. Boom. All these plates are going to be cracking and breaking all over the place. So is there any way we could fill in all the space between all of these ceramic plates with something that's a little bit, has some give to it, has some flexibility to it, so that as the fingernail bends, all these plates don't just crack everywhere, but they kind of give with it. And
like some foam or something.
So we mix some of that in there too. And then obviously it needs color too. Got to have some cool color. Maybe even some glitter if we want.
Yep, definitely.
That's not necessarily accomplishing a lot in terms of the chemical structure and integrity of what we're trying to coat our nail with, but it certainly is the reason we're doing it.
100%.
I mean, I guess you could do like a clear kind of coat that looks all shiny and stuff, but most of us are wanting to show our stuff, really stand out.
Definitely.
So we add some of that in there too. And then our plates are glued down all across this fingernail. They've got some plasticky, like flexible stuff in between all of them. We've got some color going on, and we've got some sparkliness too. And am I missing any of the many things? Oh, yeah, there we go. Also, it's going to be out in the elements all the time. It's going to be out in the sun. And you know that if you just leave a plate out in the sun all the time, or basically pretty much anything that's just like a normal object in the sun for a long time, the sun has its way with those things. So we're going to add an element to protect it from the sun that will be able to take in the UV of the sun and kind of reroute it into heat or something, dissipate it, instead of affecting our colors and our plates and all of our stuff.
Yes, definitely. That's a good analogy. The brittleness of the plates, I think, was really helpful. And the fact that they could slide all over. They could make a film, but they could go everywhere so that we have to glue them down. That was good. I'm impressed.
Does that very thrown together analogy hold up chemistry-wise too?
I think it does hold up chemistry-wise. I mean, except for why would you want to coat your finger in a million tiny little ceramic plates? But
what is
hey,
a polymer but tons of tiny somethings at least, even if it's not plates?
That's true. Tons of tiny somethings. That's exactly right. Well, I think that was a really good analogy. And I hope that you found this to be informative. I was a little concerned, but I'm glad that you found a good analogy. That was really good.
That was definitely informative. I just did not expect there to be that many things going on. I thought you would just say, like, okay, it's a color and it's a polymer that is a color and it's in a bottle. I thought that'd be kind of it.
Yeah. It's a lot more than that.
But it's, definitely more than that.
Okay, well, here's some fun snackable info bites for you. One, gel nail polish. What?
You said snackable, and then I said, like, meaning like yum. And I just kind of hated that a little bit.
Well, I loved it. Leave it in. Okay. So gel nail polish is different. It doesn't just evaporate. We'll get into that probably on a different episode, but it has a different mechanism for setting its polymer.
Okay.
Those are the ones you have to put under the UV light to get them to dry.
Oh, I've heard of that.
They're different. Mm-hmm. When you're painting at home with regular nail polish, it is always advised that you're going to have a stronger overall polymer in any application if you do several thin layers and let them completely cure. That's if you're painting regular paint, if you're painting nail polish, anything you're doing, you want a thin layer, let it completely dry or cure or whatever it's doing, and then do another thin layer. And your overall hardness will be better than if you do a really thick, goopy layer, because the polymer is going to set depth and width in that case. So it's not going to be as good.
I think I remember you saying that about some of the other polymers we've talked about in the past. Something like that. The multiple layers really makes a difference.
Yeah. So if you're I was going to say little kid. If you were a little kid like me, when I painted my nails, I really wanted to have a nice thick coat, and it always ended up goopy and gross and like would never really dry fully. And it was just a nightmare. So try to be patient and do one thin coat, let it dry completely. This is why I'm not good at nail polish, because I am not patient. And then do another thin coat and let it dry completely. That's going to be better for you.
Got it.
Chemically, science supports several thin coats. And finally, nitrocellulose was originally used. Nitrocellulose-based paints was originally used to paint cars. And then nail polish adaptations came around. It was so popular that within 4 years of it debuting in 1920, it covered all of General Motors cars.
Wow.
They've moved on from that since then, but that was sort of the origins of nitrocellulose containing paints. So that was in the auto industry, and then they moved over into the nail polish industry, and that has stayed a constituent of most nail polishes.
Wow. Interesting.
Yeah, isn't that so cool?
Yeah, seriously.
So those are my fun facts for you about nail polish. Is thin layers are always better. Gel nail polish is different.
Nice. Than
regular old nail polish, chemically, molecularly. And finally, nitrocellulose is on cars somewhere. Basically, nail polish paint used to be used to paint cars.
Wow. That's crazy. Dude, very cool. This is an interesting episode, especially for someone who I just don't use nail polish as much as I used to, you know?
Right, definitely. Well, and I think nail polish is one of many cosmetic requests we've got. People have asked a lot about cosmetics. So actually, the way this episode started was because someone wrote in and asked us about how acetone removes nail polish. And that was in our Instagram messages, and I can't search Instagram messages, so I've lost that. I don't know who it was, but if you send us another message on Instagram and remind me of your name, I'll give you a shout out in the next Q&R episode. But they asked how acetone removes nail polish. And before we could even touch that, we definitely had to talk about how nail polish attaches in the first place.
Nice.
So to answer that question, I want to say acetone is a solvent that can dissolve all of those things back just as if when it started. Way it's dissolved when it started. So basically it returns it back to its liquid state by dissolving those back off. And that's how nail polish remover works.
Wow. Interesting.
It makes those polymers be able to slide past each other and dissolves them in solution.
Mm-hmm.
So I wish I knew, that was my last little bit of information. I wish I knew who it was that had asked about that. I'm so sorry. I tried to look back through our Instagram messages and find it, but please, please, please reach out to me so that I can give you a shout out on the next Q&R episode. But we've got a lot of questions about cosmetics, so I would expect some more of those cosmetics to come up in the future.
Nice.
So that's it. That's all I have for you about nail polish this week.
Nice. Is it time to talk about our weeks and if we've had anything happy happen?
Yes, it is. It's time for that. So do you have anything happy you want to talk about from this week?
I think I do. What's funny is that I've noticed that there's a bit of a trend sometimes where the happy thing is sometimes like just shy of a product endorsement of some kind, where it's like, I've been trying this new thing. And it's so funny because these are not ads, even though it would be cool if they were or whatever. But I have been trying out a new hair product that I want to bring it up, especially because I'd really love to get your thoughts on it eventually if you have a chance to like look at the ingredients of it.
That goes with the theme of cosmetics.
Heck yeah. So check this out. It is a hair wash, you could say, the word wash maybe, that is not shampoo, that is not soap.
Okay.
And the whole point of that, there's the, back and forth, a lot of people who get really dive deep into like hair care stuff, quickly learn how bad shampoo can be for your hair. And how there's just a lot of not ideal stuff going on that are the norms of what are mostly in a lot of our like hair washing products. So this company was like, what if we start from scratch? We try to figure out something that can clean your hair. You obviously, some people just settle to like not wash their hair very often, which is how I do it. And so I shower, but
me too.
But don't wash my hair very often, which means that my head and scalp don't get cleaned, but the rest of my body does. And so the thinking was, what if we came up with something that's not soap or shampoo, so it doesn't have the uniquenesses of soap, which obviously strip oils out just by being soap. They're able to interact with the oils instead of leaving them be. What if we came up with something that did not mess with the oils and just could clean your scalp?
Interesting.
And so that's what I have been using for 4 days now.
And do you like it?
I do like it. It's hard to tell so far because I think my head is getting used to it. Like the first day, I was like, it looks like I didn't wash my hair. It looks like greasy and stuff, but I'm not going to put dry shampoo and other stuff in it. I'm going to just leave it be, try to let my head get used to it. But I'm very just super fascinated by it. So I feel like it's really, who knows if I'll end up loving it for sure, but it's been such a interesting experiment. And that has got me really curious. It feels a little bit like some of the coffee experiments I do, where like I might not end up changing something about my life, but I'm just really excited about the process of experimenting with it.
That sounds fun. I would love to look at the ingredients and see what I can come up with from that. That'd be really interesting. Because
I don't know exactly how I feel, I'll not name the name of it. If anyone's really super interested, they could message us or something, but it just seems too early to say either way. And the thing that's really interesting is not the brand or the name, but more like that it's not soap or shampoo.
Yeah. That is interesting. Well, if we're going on the theme of product endorsement, I think I'm going to go with, well, two things. I was sick off and on for a lot of October and part of September. It was very weird. It was just this like low grade sinus infection type illness that I could not shake. I had to take 2 rounds of antibiotics. It was brutal. So basically all I did in my free time was lay around and sleep as much as I could.
Dang, yeah.
But I'm getting back to feeling better. And I've been able to both start skating again because I just could not skate.
Nice.
I was too tired to make the drive, do anything. And that was so good and beneficial for my soul. Just makes me so happy to see my friends and be on the ice and just do fun stuff on ice skates. It's just great. So that made me really happy. And I'm also starting back up on Erica Davis Fitness, which we talked about a little bit in our ad.
Nice.
But that is a real thing that I really do. And I really love it. And I think it's really not very expensive, but with good accountability. And it helps me get back into my consistent active lifestyle, which I normally have a very active lifestyle, but just from being sick and with ice skating shutting down for so long and everything, it's been hard to maintain that consistently. So Erica Davis has really helped with that a lot. So I'm really excited to start back up on Erica Davis Fitness and to be ice skating again. I'm feeling very much like I'm active and I'm getting to do back into the things that I like doing after being a weird low level of sick for a long time.
Nice, dude. Yeah, that would feel great. That's a huge benefit. It's like bad enough to be sick, let alone feel not like doing anything and over time not being active and stuff. So that's awesome.
Yeah, it's been feeling really good. So that's my happy thing for this week.
Nice.
Well, thanks, Jam, for coming and endorsing your products to us always.
Anytime.
And thanks for learning about and coming up with a great analogy for nail polish and how it's little tiny ceramic plates on your finger. And thanks to whichever listener wrote it in to ask about how nail polish remover works. I really appreciate that. Please let us know your name so that we can mention you on our Q&R episode, give credit where credit's due. And we love hearing from you guys. So thanks so much for writing in.
Absolutely. And thank you for teaching us. Like Melissa said, a lot of these great ideas come from y'all. So we want to hear your ideas, the things you're curious about, things that strike you in the middle of your day that you wonder, is this chemistry? Please send those to us. Reach out to us on Gmail, Twitter, Instagram, and Facebook at Chem for Your Life. That's Chem, F-O-R, Your Life, to share your thoughts and ideas. The chances are that it probably is chemistry, by the way. So
oh, yeah, definitely.
let's figure it out together. If you'd like to help us keep our show going and contribute to cover the cost of making it, go to ko-fi.com/chemforyourlife and donate the cost of a cup of coffee. If you're not able to donate, you can still help us by subscribing on your favorite podcast app and rating and writing a review on Apple Podcasts. That also helps us to be able to share chemistry with even more people.
This episode of Chemistry for Your Life was created by Melissa Collini and Jam Robinson. References for this episode can be found in our show notes or on our website. Jam Robinson is our producer, and we'd like to give a special thanks to In Newell and A. Hefner who reviewed this episode.